Welcome back, everyone. I have set up an insane lighting rig in this house. I have a hanger holding up a lamp. Hopefully the lighting is good for you today because if anything moves, everything I own is going to be broken. Let's dive into today's Advent of Code video. Haven't looked at problem number 2 yet, but yesterday we got 2 gold stars, so that's pretty good. Just like before, I'm going to get started using Elm. This CodePen-like environment allows me to write stuff over here. Hello. We can put in our puzzle input, and then we can write some code together, and we can see if we get the right answer. So let's dive right into it. I'm going to include a link to the template in the description if you want to try this yourself. So feel free to pause the video if you want to do that. If not, let's do it. Let's do some weird functional programming garbage. All right, red-nosed reports. Fortunately, the first location of historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion/fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data, which is our puzzle input, consists of many reports, 1 report per line. Each report is a list of numbers called levels that are separated by spaces. Okay, so levels, 5 levels, 6 reports. Okay, great, 6 reports, 5 levels. Engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing, so a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing, and any 2 adjacent levels differ by at least 1 and at most 3. Okay. So in the example above, the reports can be found safe or unsafe by checking the rules. So 7, 6, 4, 2, and 1. Safe because all the levels are decreasing by 1 or 2. These are unsafe because even though they're increasing, we get a jump from 2 to 7 here. Unsafe because 6 to 2 is a decrease of 4. Okay, great. And then unsafe because 1, 3 is increasing, but 3, 2 is decreasing. So it looks like these are within the healthy bounds, but they change direction. Unsafe because 4, 4 is neither an increase or a decrease. So it looks like you have 2 safe levels here, so we're going to report 2. So we're going to analyze the unusual data from the engineers and find out how many reports are safe. So that shouldn't be too bad. Let's see if we can take the practice puzzle input. I'm going to go into the settings here. This is day 1, or day 2, part 1. My hands knew what it was. We're going to do this. So I'm going to save this and let's get started. All right, so we've got our input. I hit compile over here and we've got all this text right now is a single string. What I want to do first is I want to break that string into a list of strings. So break it up by lines. So now I've kind of got each report on its own text field here. And what I can do is I can run it through a list.filter. And I can filter and say, is it safe? So what I think I want to do before I filter is it safe is I want to map and also do string.words so that each one of these numbers gets isolated. We did a little bit of this in the last video, but now I'm basically splitting by spaces. This is the same idea as saying string.split by space. So these two should work the same. But what I want to do is I want to take a list of these strings and I want to turn these all to numbers so I can do some math on them. So for each of these items, I'm going to filter map with string.toInt. So in yesterday's video, we learned about filter map. Filter map is what gets rid of all the justs in front of everything. So we're going to use filter map. And now we've got our puzzle input kind of formatted in a nice way. It's not just a big block of text anymore. It's actually something that we can work with, which is nice. So what I need to know is for each one of these, I want to know if these things are safe. So that's going to give me a list of integers. So I can make a little type alias here for a report, where a report is just a nickname for a list of integers. And so I can determine if a report is safe by returning either true or false from this function. So if I return true, it's going to keep all of them. If I return false, it's going to keep none of them. So what I can do is I can say, this will return true if all the numbers are increasing, all the numbers are decreasing, and like all the differences are within a safe range. So the levels are either increasing or decreasing. Two adjacent levels differ by at least 1 or at most 3. So 1 through 3 is a reasonable range. And that's it. So what I might want to do is I want to say list. I think what I want to do is I want to map through and get the differences. So previously we were basically taking all these numbers and running them through a function that turned them into like yeses or nos, trues or falses. What I'm going to do instead is I'm going to, report. Oh, I'm going to get rid of this comment here, or this annotation. We'll come back to this once we implement is save. But what I want to do is I want to start to get like the differences between each of these numbers. And I know a cool way to do this. You can do list.map2 and you can do subtraction. So the idea is it would do like A and B, it would do like A minus B, that kind of thing. So if I wanted to do A's minus B's, it could be like 7 minus 6, 6 minus 4, all these differences. So a cool trick to doing this is if you take a list and you drop the first thing, you can run this through a list map too and actually like kind of pair up each thing. So 7 will pair with 6. Let me show you with a tuple what I'm talking about. So I do this. Notice that when I'm mapping 2 and I'm kind of grouping these together with a tuple, it's going to put all of the pairs together. So I had 7, 6, 4, 2, 1. This is a trick that's going to allow me to basically group neighbors together. And if I can group neighbors together like this, what I can do is I can say take A and B and subtract A from B. So here I have the differences. This looks like it's doing the wrong order, so let me do B minus A. So what this is saying is that 7 to 6, that was a negative change. 6 to 4, that was a negative change. And so now that I have these differences, I can say 2 differences. What this is doing is this is taking in my report and giving me a list of differences. And difference is just a nickname. We're going to use type aliases a lot today to represent like what's the delta between these two. So we can call difference delta, we can call it whatever we want, but we're going to use that as a way to kind of keep our code easy to read here. So now that I have a list of these differences, I think this is going to be an easier data type to figure out, are they all increasing, all decreasing, and are the values this easy to work with. And the reason I think that is because what we can do is if you give me a list of these differences, I can return true or false for a few like conditions. So let me move this up here so we can kind of keep it all on the screen. So what I need to know is do all of these, are all of these like negative, all of these positive, that kind of thing. So I can say, are all of these greater than 0? That'll return true for each of these that are increasing as they go. So if I did a map here, what you'd see is that false, true, false, 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 true. It's returning true for all the rows where it's always increasing. I could similarly, let me copy this, we're going to need it in a second. I could similarly say, hey, return true if every number in this row is less than 0. If all the differences are less than 0, that means that these are all decreasing. So notice this is true, this is false, this is true, etc. So what I can do is I can say all increasing or all decreasing, and values are between, I can say 1 and 3. So what I like to do is make little helper variables here. So this will be okay if this is true and all values are between 1 and 3. What I can do is I can just take this, say all decreasing is this, and list.all is a thing that's built into the core library, so it makes this a really easy job. It's all increasing if all the differences are greater than 0. And then finally, values are between the min and the max. What I can say is that the list.all, so every number, every difference that I put in, the absolute value of that is greater than or equal to the min, and the absolute value of that difference is less than or equal to the max. So when I put all that together, what we end up with, values are between, oh, and I forgot to include diffs here. So let me click format, and we're gonna let Elm format snap everything into place. So I'm gonna do this. And so what this is hopefully gonna do is say true, false, 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 true. And so it's saying this is good, this is bad, 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 and this is good. And if we look at the practice problem, that matches our safe, unsafe, 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 safe. So this looks like it's working the way we expect it to. If we wanted, we could annotate these with booleans. I'm gonna do that just for fun, because I have fun typing. And then just to give you a sense of what this is an integer to an integer to a boolean. So if you give me 2 numbers, I'm going to be able to give you these. And in the last video, we didn't really work too much with these helper functions, but this is basically is negative. And we can break that out into its own function below. We could make it local inside of this in like the let block. What I'm going to do is I'm just going to say is negative is when x is less than x equals 0, is positive, and making these helper functions keeps this code readable. Elm's kind of a weird language. It's really intimidating to people who are new to it. So it's really helpful, especially if you're working on a team, to try to make your functions, try to name them as much as you can, are within bounds. So we can do this too, are within bounds min max value. So that value is what we were calling x previously. So these are all the same way to kind of run the same code that we had. So we should still get the same answer, true, false, false, false. So all I'm going to do is just annotate these. If you give me an integer, I will return a boolean. For is positive, if you give me an integer, I'll return a boolean. And for are within bounds, if you give me the min, you give me the max, and you give me the value, I'm going to return a boolean. Are these things within bounds? This is kind of a silly name because the absolute value, it's not really a great name, but I'm going to leave it like that for now. Because it's easy to say in English for a YouTube video. So what I'm going to do here is I'm just going to do list.length. That's our answer. Oops, list.length. We're going to do a filter instead of a map. And that's going to say everything that returns true, we're going to keep it. And then we're going to do a list.length to figure out how many we have. So the answer for this example was 2. What I'm going to do is I'm going to open up my puzzle input. I'm going to copy all of this. And what I'm going to do here is I'm going to save this. And then I'm going to paste in my puzzle input. I get 564. So let's see if 564 of these rows are safe. And they are. Looks like our code worked. Okay, so for part 2, we're going to basically have a little twist on the problem. We're going to see what bits of our code we need to change. Before I get distracted, I am going to copy this, and I'm going to put this in part 1. So this link, this answer, will be in the description of the video for you. But yeah, let's dive into part 2 and see what we need to do next. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. Problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. More of the above examples reports are now safe. So this is safe without removing anything. Still unsafe, still unsafe. This is safe if we remove 3. This is really interesting, actually. This is safe if we remove 4. And this is safe from before. So then we still need to figure out what's safe. Interesting. So not only do we want to run it against the levels that come in, if it fails, we want to basically remove as many levels, remove 1 level at a time from the list. And if any of those are safe, then we should be okay. So I think a lot of the code we have is in place to do this, but it looks like with the puzzle input, we should see 2 and 3 are still unsafe, but the rest are going to be safe for an answer of 4. So let me go back. I'm going to comment this out. Let's go back to this, because this will tell us which ones we need to check. So this is with the old code. Let me change the name here to part 2. I'm going to just save this as is for now. And then hopefully remember to update that link for the video. Cool. Okay, so what I think we want to do is safe. I'm going to do this. I'm going to say if it's safe, and we do true. This is like is safe without modification. Otherwise, I think we want to is safe. I'm trying to figure out what to do. So this was I like this function as is. It was working pretty well. But I'm going to say is safe with modification. You're going to give me a list of diffs. And I'm going to say, all right, if that list is safe, we're good. And for now, I'm just going to return false. This is a silly expression because it's going to give us the same result as before. And using an if statement that returns true in the first branch and false in the second is kind of a little red flag, but we're not going to keep it this way. But what I'm going to do is I'm going to use this one here, and hopefully we still get the same output. Great. So the answer should still be 2. Oh, sorry, I keep doing that. If we filter by that, we still get 2, which is good. So let's leave that like this. What I want to do is I want to use this function. I want to reuse it for this problem. But what I'm going to do in this else branch is going to change. So here I'm going to say basically try with all the like variations of the list with 1 missing element. This is what I'm going to try to do here. So what I can do is I can use the list .any function to say are any of these values, you know, where I drop 1, I drop 2, I drop 3, that kind of thing. So if I have my list of differences, let's go back to what that looked like before I messed with it here. I'm going to say false. We'll come back to that. So I have this -1, -2, -1 thing. This is actually too soon. I don't want this. What I want is this list. So what I'm going to do is I'm going to actually move the 2 differences into here. So I'm going to update this function, take a report. I'm going to go to differences for that report. This is why the type annotations really do help. Because now we can kind of talk about this. This was a list event and this was a list events. But now it's really clear what's going on. So is safe is going to work on a report now. So let's try this again. So we have this. We're not going to do the 2 differences here. Instead, we're going to run is safe with modification on this report. We still get the answer that we had before, which is good because we didn't change this branch yet. But what I want to do is I want to basically get all the variations of the report. So if we think about that, it's going to be like if my report is 76421, I want to basically get a list where I'm doing, hey, let's get rid of this hey, let's get rid of this. Let's get rid of this. Let's get rid of this. I want to enumerate all those possibilities. So this is going to be a list that I'm going to run is safe against. So instead of saying list.false, I'm going to say list.any is safe. And then I'm going to say report missing one level. So missing one level. Can be a function here. So missing one level is going to take in a report, and it's going to give me a list of reports. So if you give me a report, I need to basically do this. So I'm going to move that comment over here. So if you give me this as the input, this is the expected output. And if I have this, I can just run this through, are any of these safe or any of these variations safe? And if any of these return true, then the whole thing is safe with modification. So what I'm going to do is I got to think about, what are we doing here? We're kind of removing the element at the first index, removing the element at the, so it's like the 0 index with the 1 index with the 2 index. So my instinct is to do a list.range going from 0 to the length of the report. So if I have 5 elements, it's going to go 0 to 5. This is going to be inclusive. So I actually want to go 0, 1, 2, 3, 4. And what I'm going to do is I'm going to remove the element. Is it going to remove the element 7, 6, 5, 4, 2, 1? This gets rid of the 2. Oh, sorry. This one should be 7, 6, 4, 2, right? So if I get rid of the 7, I get rid of the 6, I get rid of the 4, I get rid of the 2, I get rid of the 1. So these are the output I expect. So what I want to do is 0, 1, 2, 3, 4. Yeah. So I want to remove the element there. That map, this is going to be my index. So what I want to do is I want to say list.drop. I wonder if there's an easier way to do this with a list. So let's go into the Elm docs for list and see if there's an easy way to kind of drop an item there. I think we might want to convert to an array because arrays allow you to really easily like eliminate something. So you can slice an array, and that'll get rid of what? So start end. Start at 0, get rid of 3. How does that make any sense? Oh, slice grabs a selection. So I don't know. I'm trying to figure out if I want to turn these into arrays or if I want to just modify the lists. Because lists are really designed to work from the front in Elm. So you can do like drop, for example. You can do drop and you can do take. This could work. Tail. So drop the first n. I think I might be able to get away with this. So I'm going to do list.take index. So this is going to take 0 from the report. And I'm going to combine that. So if I take 0, sorry, this is a function here. If I do list.take index, it'll take 0 from the report, and then it'll do list.drop. Drop. I just want to drop 1. This is confusing. I think it might be easier to switch to an array because I'm confusing myself thinking about this. I'm wondering if I want to take 2, I want to take 0, I want to take 1. This is definitely how I want to grow the front of the list. Just drop the end of the list. It might be just take plus drop index plus 1. Let me see if this works. Take index from the report, and I'm going to combine that with drop x plus 1 from the report. This might be it. And I want to debug this. I want to see if this is doing what I think it's doing. So what's really cool about working with values like this is I can just say main, equals this, and I can say 576421, and I run this through here. Do I get what I expect? So 6421, let me scroll down and see if this is right. 6421, 7421, 7621, 7641, 7642. So it looks like this function is doing what I want, and I was able to really quickly check that by just putting in a test value and then running it through my function. This is the huge benefit of using simple input-output functions. That's all you can make in Elm, so it makes it really easy to see if what you're doing is right. So I think this is working. If I hit compile, main 2, that's the issue. If I hit compile, I get true, false, false, true, 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 which is what the puzzle output said. Safe, unsafe, unsafe, and then these are all safe. So the answer is 4 for this. So let's get that answer. This time I didn't forget to do list.filter. Can't type, but that's its own problem. So this is what I expect it to be. So I'm going to save optimistically, hoping that that's it. And I'm going to try this on my own puzzle input. And we will see if I nailed it or if I failed it. 604. It makes sense that that number is higher than the previous answer, so that's already a good sign, but we'll see if I screwed something up. I didn't. It worked. My goodness. Pretty sick, pretty sick. So it looks like, we've got 2 days down. That's 2 admin codes. Hopefully that was easy to follow. I'm going to have the links to all this below. I'll catch you tomorrow, and I'll be there for day 3. Usually day 3 or 4 or 5, they start sneaking in the hard problems. We'll see how it goes. But goodbye.